Six formulae. First formula that I am going to discuss is this: integral dx upon a square plus x square. This particular formula is applied whenever we have denominator a quadratic function. So we will be learning later on what is the application. First I am going to only discuss the formula. It is 1 by a tan inverse x by a. It is very easy to understand this formula belongs to this category, because if I take an a square common, it becomes 1 plus x by a the whole square. And this 1 by a square is removed outside, and you have 1 by x by a the whole square dx. We know that derivative of tan inverse x is 1 upon 1 plus x square. Therefore, integral of 1 upon 1 plus x square dx is tan inverse x plus c. So I can say from here, therefore the integral of 1 by a square will be 1 by a square integral 1 upon x by a the whole square will be 1 by a square into tan inverse x by a divided by the coefficient of x. Here the coefficient of x is 1 by a. When you say coefficient of x, inside the square, what is the coefficient of x? Plus c. So a and a will get cancelled, and that's how you get this formula. This is one way of proving the theorem. But I am not going to use this method. I am going to use substitution method, because all of them work in the same manner. I will put x as a tan theta. So in the board examination, you will be writing this proof and not this one. So naturally I need to replace dx, so differentiate with respect to theta. So a sec square theta, cross multiplying dx equal to a sec square theta d theta. So your left hand side becomes a sec square theta d theta divided by a square plus a square tan square theta. If you take a sec square theta d theta and a square common, you get 1 plus tan square theta. And you know that 1 plus tan square theta is nothing but sec square theta. So I can write this as a and a square get cancelled. 1 by a sec square theta divided by sec square theta d theta. So they also get cancelled. It is 1 by a integral 1 d theta. Remember, the variable is theta. Integral of 1 dx is x. Integral 1 d theta is theta. So 1 by a into theta plus c. Now what is theta from here? What is theta from here? Tan theta is x by a. So what is theta? Tan inverse x by a. So I can write here as 1 by a tan inverse x by a plus c becomes your answer. So this is a method that you need to apply in the board examination for proving this theorem. Integral dx upon x square minus a square. What we do is, here there is no substitution, just simple factorization. You factorize the denominator as x minus a into x plus a. And what you notice is their difference, x minus a, x plus a minus x minus a is a constant. And I can always divide and multiply by a constant. So I am going to divide and multiply by a constant. And why did I select this 2a? Because 2a is the difference between the denominator term, so that the numerator 2a can be expressed as the difference of the denominator term. When you do this, there is a possibility for us to separate the denominator, x minus a into x plus a minus x minus a upon x minus a into x plus a. You will notice that one term get cancelled. So I can write this as 1 by 2a into integral of 1 over x minus a dx minus integral of 1 over x plus a dx. So I can write this as 1 upon 2a log of modulus x minus a, because you know derivative of log x is 1 by x, integral of 1 by x is log x, so 1 by x minus log x minus a, into log of x plus a plus c. So my answer became 1 by 2a log of modulus x minus a upon x plus a. So how will you remember this formula? Just have a look at the formula. The method to remember this formula is like this. First of all, you divided and multiplied with 2a to get this answer. So it has a prefix 1 by 2a. Then ask the question, what are these factors? There are two factors there. One factor is x minus a, which will come to numerator, and second factor, x plus a, will come to denominator. This is how you need to remember the formula. First of all, you divided and multiplied by 2a because the difference is 2a. So 2a becomes your prefix, 1 by 2a becomes your prefix. Then log of the numerator will be the x minus a factor, and and the denominator will be x plus a factor. The factors of this, minus in numerator and plus in the denominator. This is how we need to do this. Now we come to the next formula, integral dx upon a square minus x square. So previously it was x square minus a square. Here the variable, a constant is first and x square is negative second. Okay, so same method, factorize the denominator, a minus x into a plus x. You need to try this yourself. Try to do this one yourself without seeing what I am doing. Now divide and multiply with 2a. This time 2a can be written as the sum of the denominator term. 2a can be written as sum of the denominator term, a plus x plus a minus x divided by a minus x into a plus x dx. When you separate this, integral 1 upon a minus x dx plus integral 1 upon a plus x dx. Like the previous one, I am not giving much explanation. When you separate it, a plus x got cancelled, a minus x will remain. When you separate this one, a minus x will get cancelled, a plus x will divide. Now be careful about the integral. This is 1 by 2a log of a minus x. But x is having a coefficient here, so you need to divide by minus 1. The x is having a coefficient, x coefficient is minus 1, so you need to divide by minus 1. Here log of a plus x. Here there is coefficient is 1, so we don't have to write that. Now because of this minus, this became negative. So 1 by 2a log of a plus x will come to numerator and a minus x will come to denominator. That is log m minus log n is log m upon n. So your conclusion here, whenever I want to integrate a constant minus x square, your formula is 1 by 2a log of, the factors here are a plus x in numerator and a minus x in the denominator. This is the format of this answer. Now we will take quadratic with the root. Let's check this formula, dx upon root of a square minus x square. The formula for this is sine inverse x by a plus c. So proof of this is done by substitution method, sine inverse, so put x as sine theta, x as a sine theta. Naturally theta has to replace back. So from this I can say sine theta is x by a and theta is sine inverse x by a. So in the last step, I'll be replacing theta by sine inverse x by a. For that purpose, I've written this. Now, whenever we do substitution variable, the dx has to replace. For that purpose, we differentiate with respect to theta. So you get a cos theta. So in place of dx, you will be replacing a cos theta d theta. So this dx will be substituted as a cos theta d theta. So I can say the integral will be, instead of dx, a cos theta d theta divided by root of a square minus a square sine square theta. Now this I can write as a cos theta divided by root of a square, if I take common, 1 minus sine square theta. So root of a square and a will get cancelled because root of a square is a. Cos theta, 1 minus sin square theta is cos square theta, root of that also will get cancelled. So you will be left with only 1. The variable of integration is theta. So it becomes theta plus c, and theta is going to be replaced by sine inverse x by a plus c. This is your second formula. So one important thing to note. Previously, when I was doing without root, so basically we have two categories of formulae. One having square root and one don't have square root. If you have, of course we have done plus, minus, etc. If you don't have square root, you will start with a prefix. If you have square root, no prefix, it's directly sine inverse. And that's all we have to remember. The sine inverse x by a plus c. This will be 1 by a tan inverse, because tan inverse x derivative don't have root. Sine inverse derivative has root. So that's why you can compare and learn. So this prefix to be noted. If there is no square root, there is a prefix. If there is a square root, there is no prefix. This is what you have to remember. Next formula that we have is integral dx upon root of a square plus x square. So now root has come with the root a square plus x square. The formula for this is log of x plus denominator, whatever the denominator here. This also has no prefix here because there is a square root. Method here is put x equal to a tan theta. I think we already know the reason behind put x equal to a tan theta. If you replace x by a tan theta, 1 plus tan square theta is sec square theta. Root will go away. That is the reason. So dx is equal to, dx by d theta is equal to a sec square theta. So in place of dx, I will replace a sec square theta d theta. So my integral left hand side became a sec square theta d theta divided by root of a square plus a square tan square theta. That became a sec square theta d theta divided by root of a square into 1 plus tan square theta. This is how we can simplify that. This and this will get cancelled. You will be having integral numerator sec square theta, but denominator there is only sec theta. So 1 sec theta remains in the answer. Now when you integrate this, log of sec theta plus tan theta plus c1. You know the integral of sec theta is log sec theta plus tan theta. Why did I write c1 is, my final answer should have c. But that constant c1 is going to change. Now I need to replace them in terms of x. What I have from here is tan theta is x by a. So my substitution is going to be tan theta is equal to x by a. My substitution is tan theta is going to be x by a. But here we have sec theta also. So what I am going to do here is, I will write this as log of tan theta first of all, this tan theta. Sec theta I am going to write it as, you know that sec square theta is 1 plus tan square theta. So I can write 1 plus tan square theta whole under the root. Now sec theta I will replace by x by a. So log of x by a plus root of 1 plus x by a the whole square plus c. 1. Now what I can do? I can take the LCM here. This is a very important step. So a square I can take LCM. X plus root of a square plus x square. Now this a square is inside the root. So outside the root it will be a. So in this a square came over here upon a square, but a square is inside the root. So when you take the root it will become only a. This became log of modulus x plus root of a square plus x square minus log a plus c1. I told you there's going to be another constant. So this both constants is added and that's how you get the c. So your final answer is log of x plus denominator. What do you mean by denominator? This is a denominator. A square plus x square plus c, where c is minus log a plus c1. Because it's a constant, so I added together, got a new constant. That new constant is denoted by, next formula is integral dx upon root of x square minus a square. This is also same previous formula, there's hardly any difference. Log of x plus denominator. But the proof has different substitution. Last time we had a square minus x square, then x square plus a square plus x square, plus we put tan theta. Here naturally you will put x as a sec theta. So that sec square theta minus 1 is tan square theta, square root can be removed. So dx will by d theta is a sec theta tan theta d theta. Derivative sec theta is a sec theta tan theta. Then dx by d theta got cross multiplied. Also we can say from here sec theta can be replaced by x by a. So my substitution, so left hand side will be, instead of dx I'll write a sec theta tan theta d theta. Denominator will be root of a square sec square theta minus a square. If you take root of a square common, sec square theta minus 1, that is a sec theta tan theta divided by root of a square into tan square theta. Now root of a square and a will get cancelled. Root of tan square and tan will get cancelled. So you will be having only sec theta like last time. Integral of sec theta is log of sec theta plus tan theta plus c1. This time sec theta is x by a. So you need to express tan theta is also in sec theta's form. So log of sec theta plus root of sec square theta minus 1 plus c1. That became log of x by a plus root of x by a the whole square minus 1. Now take the LCM like the last time. There's hardly any difference. These formulae are very important. The proofs are very important for the board exam point of view. They do ask this proof. That's why I have taken care to teach you this proof. X square minus a square minus log a plus c1. And minus log a plus c1 will be combined to a single constant. So you get answer as plus c. So these are the 6 formulae that we have derived. We'll just revise all the 6 formulae once again. Let's try to remember the formulae. We had first 3 formulae. One is a square plus x square. Then we had, let me write it as 1 upon. It'll be better to understand that way. 1 upon a square minus x square. 1 upon x square minus a square. These are the first 3 formulae. Next 3 formulae were 1 over root a square plus x square. Then 1 over root of a square minus x square. And 1 over root of x square minus x square. This is how I try to make you remember. I know the derivative of tan inverse x. This is 1 upon 1 plus x square, which implies integral of 1 upon 1 plus x square is tan inverse x. Same way, I know the derivative of sin inverse x. 1 upon root 1 minus x square. What does that mean? 1 upon root of 1 minus x square dx is sin inverse x. If you look at this formulae, a whole set of formulae, you notice that this and this are of the same format. Sorry, this and this are of same format. A square in place of a it is 1, it turns to tan inverse. In place of a it is 1, it turns to sin inverse. So the answers for this both will be tan inverse and sin inverse. All others will be in log. So that's all to remember. Then second, as I told you, there is a prefix when there is no square root, and when there is square root, there is no prefix. Prefix for this is 1 by a. The prefix is 1 by a. Here there is no prefix, so it is sin inverse Instead of x, it is x by a. In tan inverse is tan inverse x by a, and so when there is a square here, x upon a it will become. When a square here, x upon a it becomes. These two are factorizable. So 1 by 2a, because factorization we did 1 by 2a, log of, when constant is first, a plus x. When x is first, x minus a in numerator and x plus a in the denominator. So when constant is first, numerator is a plus x upon a minus x. When x is first, x minus a upon x plus a. Here the answer is log of x plus denominator. This also log of x plus denominator. So these two are very easy to remember. Log of x plus denominator, log of x, no prefix. So both of them log. Here you use factorizable. So a plus x upon a minus x. Here not factorizable, log x plus denominator. Non-factorizable, root is there, log x plus denominator. Factorizable, 1 by 2a, log of, if it is a first, a plus x upon a minus x. If x first, x minus a upon x plus a. That's all to remember. Now we will learn how to apply this formula. Let's take an example. Integral dx upon 25 plus x square. Integral 1 upon, instead of dx I may write 1 also, x square minus 9, and integral 1 upon x square 16 minus x square. First I'll teach you these three problems. Here a square is 25, a square is 25. If you need to compare 25 plus x square, you compare with this. X square minus 9, compare with this. 16 minus x square, compare with this. There is a square plus x square, so 1 by a. It is 5 square here, so 1 by 5 tan inverse x by 5. So directly you can write the answer. You don't have to do any calculation substitution. Directly 25 became 5 square, so 5 came here, tan inverse x by a. Here if you compare x square minus a square is 9, so a's value is 3, so 1 by 2 into 3, log of x minus 3 upon x plus 3. So directly you can write the answer. So 1 by 6 you can write. Here again 1 by 2 into a square is 16, so a is 4, 1 by 2 into 4, log of 4 plus x upon 4 minus x. This is how you can apply that. Now you will ask me the question, suppose this was not a perfect square. What would you do if it was not a perfect square? Let's have a look at it. Suppose I had here 5. Then my answer would be 1 by root 5, and this will change to root 5. So if it is a number here which is not perfect square, because 5 can be written as root 5 the whole square. So when you compare this both, a became root 5. So whatever the number here, its root comes over here. Then second, my question to you is, what will be there if there is a coefficient for x square? For example, let's say I have a problem like this. 1 over 9 plus 4 x square dx. You can see the coefficient of x square everywhere is 1. So one option you have is you can take a 4 common. You can write this way. 1 by 4 integral 9 by 4 plus x square dx. This is one option you can have. Make the coefficient of x square common by taking a 4 common. When you take a 4 common, 9 becomes 9 by 4. Now I can write this as 1 by 4 integral 1 by 3 by 2 the whole square plus x square. Now my answer became 1 by 4, 1 by a, 1 by a is 3 by 2, tan inverse x by a, that becomes 3 by 2. So this 2 and this will get cancelled. So 1 by 6 tan inverse 2x by 3 plus c. This is one method of doing this. It's a little lengthy method. I have another method of doing this problem. I can write this as directly 3 square plus 2x the whole square. I prefer you to do this way. If you apply this formula now, a square is 3, x is 2x. Now x is having a coefficient. So 1 by 3 tan inverse 2x by 3 whole divided by coefficient of x. Now this 3 into 2 will become 6 and you will directly get the answer. So we will try to do in this manner. Whenever there is x is having a coefficient, but when you take the coefficient, it should be taken inside the bracket. Do not take it 4 as a coefficient. It is 2x the whole square. Now coefficient of x is 2, so divide by 2. The coefficient of x is taken inside the square, not outside. So that's why we are dividing by 2. So all the time you be careful about this. Now let's learn how to apply this formula. Integral dx upon root of, let's say, 4 plus x square. First ask the question, is it sine inverse? What is the derivative of sine inverse? Derivative of sine inverse will have a negative sign. So if it is 1 upon root of 3 minus x square, this would be sine inverse. If it is 1 upon root of x square plus 2, this will not be sine inverse. Or x square minus 2 will not be sine inverse. This alone is sine inverse. So you will write sine inverse x upon coefficient of a square. A square is 3, so a is root 3. This is very easy to write answer. There's no prefix. So sine inverse x upon a. A stands for root of this number because a square is 3. A square is 3, so a is root 3. This and this are very easy to write the answer. Log of x plus denominator. This also log of x plus denominator. So very easy to write this to answer. So comparatively root formula is easier. One alone, remember, this is the derivative of sine inverse matches with this. So root of a square minus x square is sine inverse. Other two are log of x plus denominator. Now let's see next type of question where I am going to have x square as, let me put this x square as dx upon, let's say, root of 4 plus 3x, 9x square. In this case, it is of this kind. The only thing that I must remember here is 1 upon root of 4 is nothing but 2 square, 3x square. Here, even if you don't write 2 square, it's fine. It is log of x, x is 3x, plus denominator. Either you can write this or you can write this. Plus c divided by the coefficient of x. The coefficient of x here is 3. So your answer became 1 by 3 log 3x plus root of 9 plus 4x square. So let's look at this one. If I have a question like this, if I have 2 minus 3x square, first and foremost thing, this is sine inverse because a square minus x square, sine inverse. So I can write this as 1 upon root of root 2 square minus root 3x the whole square. So my answer would be sine inverse x became root 3x upon root 2 divided by the coefficient of x, root 3 plus c. So whenever x is having a coefficient, you need to divide by the coefficient of x. It is not 3, it is root 3 will be the coefficient of x. You may write your final answer as 1 by root 3 sine inverse root 3 x by root 2 plus c. Usually we don't write like this, we write as a prefix. So prefix will come if the coefficient of x is not 1. If the coefficient of x square is 1, no prefix. But if coefficient of x is some number, that will turn to be a prefix. Let's practice few problems here. So this is integral 1 upon a square plus x square. It is similar to tan inverse x. So 1 by a, tan inverse x by a. A is root 3 square, a square. This is root is there, so no prefix. Is it sine inverse? No, it is not sine inverse. So the answer is log of x plus denominator. If it is not sine inverse, it is log of x plus denominator. Is it sine inverse? Yes. A square minus x square. 1 minus x square inside the root. So sine inverse. So your answer will be sine inverse x. What is x here? Root 3x it is. Because 3x square should be imagined to be root 3x the whole square. So root 3 become a. A is root 5 divided by coefficient of x. Coefficient of x is root 3. Now the answer for this is factorizable. So it is log of 1 by 2a is there. So let me write it as 1 upon 2 square into root 3x the whole square. So my answer will be 1 by 2a. A is a square is 2 square, so a is 2. Log of, it is a square minus x square, so 2 plus root 3x upon 2 minus root 3x, also divided by the coefficient of x. I have written the coefficient of x upon root 3, that is over here, plus c. Now you can multiply this and write your answer. So 1 upon 4 root 3 log of 2 plus root 3x upon 2 minus root 3x plus c. So very easy to remember the formulae. One which do not have root, 1 by 2a log of factors. One which has root, log of x plus denominator. Now this is similar to a square plus x square. So 1 by a is root 2, tan inverse x plus 4 upon root 2. Remember, there is no square root. Because there is no square root, it has a prefix. It is a square plus x square, the prefix is 1 by a. Whereas a square minus x square prefix is 1 by 2a. So you need to differentiate the difference between the two and then understand.